Hey everyone, Donovan Brown here. Welcome to the DevOps for ASP.NET Developer Series. In this episode, we're going to focus on advanced release topics. With release, you can do more than just automate the deployment of your code. You can also run integration tests, security scans, or deploy your containers. Let's see how Abel and Jeremy add these advanced features for their pipeline.
All right, Abel, I'm super excited. After our last talk about unit tests, I integrated some unit tests, updated them, actually found some defects that wouldn't have been caught till later. So the code's built. It's pristine, it's beautiful, but it's not running anywhere. I know it's good, I know it compiles, I know my tests run. What's the next step?
You need a deployment pipeline, right? You need to be able to deploy your code into production somewhere or into someplace.
Sure.
So luckily for you, Azure DevOps is here to help you. You can use Azure DevOps to deploy your code anywhere.
Anywhere.
Into Azure, of course.
Okay.
You can deploy your code behind your firewall, in front of your firewall, someone else's cloud. Don't use someone else, use our cloud. But the tooling literally doesn't care, right? We'll let you deploy anywhere, however you want, for any language as well, not just for .NET.
Okay.
Yeah. So if we jump to my screen, what you see here is my deployment pipeline. So when you set these things up, what you need to do is first you need to decide what stages do I have, right? So in this case here, I have a dev stage, a QA stage, and a prod stage. Pretty simple.
Okay.
Right. So after you figure out what stages you have, then you can go into each stage, and from here, you start adding the tasks that you want to run to deploy your application into that particular stage.
So a stage is going to be, for example, I'm doing QA testing. I might actually have a staging environment that is a QA-like environment that has mirrored production code and out to production and anything in between that I might want. Okay, makes sense.
Whatever you want. And actually, if you think about it, a stage doesn't even have to necessarily correlate to an environment.
Okay.
Right? A stage is just basically a set of steps that will happen at that particular stage, and you have approvers before and after each stage as well.
Okay.
So in theory, it doesn't even have to be an environment, but it kind of makes sense.
So if I go back to, I've done web development for years, but I also did a little bit of actual desktop application. So a stage might be packaging the application into a deployment package, and then I might have another stage to test the install, for example.
Yes, exactly.
Sounds good.
So your imagination is the limit of how you want to distribute these stages. So you figure out what your stages are, then you figure out what are the tasks that are going to run. Right. Okay. So this is just like the build. It's the task engine, does one task after another after another. So in my case, I'm going to go ahead and use an ARM template to deploy my ARM template into Azure, my environment into Azure.
So that's an Azure Resource Management template. Describes infrastructure basically through declarative code. Yeah,
infrastructure as code.
Yes.
So in my ARM template, I basically describe exactly how I want my infrastructure to look like. And then in this particular stage, that first step is it takes that ARM template, goes to Azure, and creates for me that exact environment that's described in my ARM template. Or if it already exists, it doesn't do a thing. Or if it exists but it looks a little bit different, it will tweak it so it looks exactly like how my ARM template describes it.
Okay, cool. So we've passed a set of instructions to the 3D printer, and it's 3D printed some cloud assets for us.
There you go. Perfect.
Okay, like a web server, for example, or a database.
Yep.
Okay.
Yep.
Sounds
Very
good.
Cool. And then once I do that, then I have a task that will take my application, which is zipped up in a zip file, and let's go ahead and deploy that into my app service or wherever I want to deploy it to.
Okay, so this one's really simple then. It's create something to run my web app, and then deploy my web app into it.
Deploy my web app into it.
Okay.
Right? So it's super simple to do. Out of the box, you get hundreds of tasks that you can just start using. Right. And you'll start seeing, man, this is for like all languages, all different platforms, whether it's the Apple App Store, Amazon Cloud, of course Azure stuff, there's going to be a ton of Azure stuff. So basically anything you want to do with Azure is already pre-built and you're ready just to rock and roll.
Okay.
If you want to do something that doesn't exist out of the box, jump into our marketplace. So our marketplace now has, I think, over 900 tasks, like build and release tasks that our partners have created. So those you can just download and start using. And therefore, if you scroll through this list, it's massive, right? And it's just for all sorts of stuff. Whatever you can think of, it probably is out there.
Now, if there's something that I need to have done deployment-wise that there's not something in the marketplace for? Is that something I can build myself in some way?
Absolutely. You can write your own custom tasks as well.
Okay.
So a custom task is PowerShell or Node,
All right.
which means whether you're on a Windows system or a Linux or Mac OS system, it doesn't matter, right? You'll be able to write a task that does whatever you need it to do. And if you really think about it, if it's Node or PowerShell, I mean, basically anything from the command line, I can write a script that does it, right? So it becomes, it's really easy to get what you want done. So what I always tell people, whether it's for your build or whether it's for your deployment, if you don't know how to set up the pipeline, ask yourself, how would I do this from the command line? And what are the steps that I'm going to do? Because most likely you'll find a corresponding task that does those steps, and if you don't have that task, you can write one.
Okay.
Right. So
Makes sense.
easy enough to customize this and make this do whatever you need it to do.
Sure.
All right, so we've defined what our environments are going to be.
Okay.
We've gone into each one of our environments and defined what are the tasks that are going to actually run. If you look in my QA environment, I think I do some extra stuff, right? I do some load testing as well.
Okay,
in my
very
QA.
cool.
So the idea is deployment application, let's pound some load, let's see if it's still working or not, right? You can do your automated UI testing here or do whatever you need to.
That's a relief because I don't want to run load tests manually every time we deploy.
Right.
So to be able to automate that is a relief.
Right. So we've created our environments, we've created our tasks that will run in each of the environments. The other thing that you need to decide is where are your artifacts that you want to deploy? Where are those coming from? Right. So these are going to be your build artifacts. If we go ahead and click on Add, you'll be able to see.
So for a very scientific definition of build artifact, that's the stuff that makes my application run.
Yeah.
So what comes out of a build,
Yeah.
basically.
So if you think about what does come out of a build, right? Usually it's going to be my binaries. There might be my ARM templates.
Assets like images.
Yeah. Images, fonts, whatever, right? It's just whatever it's just the output of your build.
Okay.
So the output of your build is stored back into Azure or Azure DevOps. It's actually blob storage, but it's all we need to know is it's held inside of Azure DevOps. And from there, if I select a build, I'm able to pick which project and which build I want to use, right? And then it will go ahead and grab that particular asset as my build artifact. And I can grab build artifacts from any build that I have, or I can grab build artifacts from an Azure repo, or from GitHub, or from if I'm using TFVC.
Now, when you tell it to grab an artifact, does that mean it's automatically triggered when that artifact is created?
That's a very, very good question. If you click right here, this will help you enable continuous deployment or not.
Okay.
So what that means is if the build is successful, let's automatically deploy this.
Okay, so it can either be a manual or an automated step.
Yeah.
Okay.
So if I make it manual, if I disable this, then the build will succeed, but nothing will happen. But I'll have to come and actually trigger this release, and it will grab the latest build, and so on and so forth.
Okay.
And actually, when you trigger a build manually, you get to select which build do I want to use. Do I want to use the very latest, or do I want to use like a one from the past or something like that as well?
Okay.
Right. So we've defined our stages. We defined the tasks that we want to run for each stage. We've defined what our build artifacts are. And you can have, I'm only using one build artifacts, but you can have more than one.
Okay.
Now you get to decide who are the approvers before and after each environment.
Okay, that makes sense.
So what I've done is I don't have an approver for a pre-deployment approver for my dev environment.
Just send it out there.
Blast
We're
it into
just
dev.
testing how it runs in the wild,
Yep.
basically.
Yeah.
Yep.
It's dev. Who cares about
Who
dev?
cares?
Yeah, it'll be fine. Right. All right. So after it's done, I sit here. I do have a post-deployment approver. I'm waiting for someone to actually say, you know what, dev looks good. Let's go ahead and dump it to QA.
Okay.
I've also added a pre-deployment approver for my QA environment. Because maybe they're in the middle of testing, they're not going to be happy if I just blast new code right in the middle of their testing.
Sure.
Right?
So from our perspective,
Yeah.
looks good, we open the gate.
Yep.
From their perspective, we may need to wait a couple days before we receive it. Okay?
So I'm giving them the option of saying, now we're ready. And then it'll go, the bits will immediately flow. Right?
Okay.
And I also have a post-deployment approver as well. So the post-deployment approver is kind of cool because when your deployment runs, you get the choice of saying, this is great, go ahead and pass it on through, and it flows on to the next environment, right? And then the next environment, if you have a pre-deployment approver, you have the ability to approve the deployment but schedule when you want the deployment to happen as well.
Okay.
So you can say, yes, I approve it to be deployed into QA, and let's go ahead and do it immediately, right? Or you can say, I do approve it, but let's wait until 2 in the morning or something like that.
Sure.
So you have the ability to do that as well. So basically, that right there in a nutshell is your deployment pipeline. Define what your stages are, define what tasks will run inside of each stage, and then go ahead and define your approvers before and after each stage as well.
So it makes sense to me deploying code through this pipeline.
Yep.
You have code package, it's a DLL, a zip file, whatever.
Mm-hmm.
I know from experience working with relational databases that you can have either schema changes to the database or even data that you need to populate.
Yes.
Can that be part of this pipeline?
Absolutely. I'm glad you brought that up because that is vital, right? Database DevOps. Database DevOps.
Say that 5 times real fast. Database DevOps, database DevOps.
Database DevOps.
Okay.
Like that. So database DevOps is absolutely vital in this DevOps world, right? Once again, we're trying to continuously deliver value. So as soon as we can, we want to deliver value to our end users. We have to include databases as part of that as well. So there are a couple different tools that you can use that helps enable database DevOps, right? Basically, you have a tool that encapsulates your schema and the changes that you make to your schema. So you can use SSDT, SQL Server Data Tools, I think. That is Microsoft's tool that literally encapsulates the schema of your database. You make a change to it, and it changes the SSDT project. Part of the build steps, it's really cool because an SSDT project is just part of your Visual Studio solution. Part of your build steps, when it builds an SSDT project, it creates for you something called a DAC pack, right? So think of a DAC pack as the schema of your database that's been flattened and stuck into an XML file.
Okay.
It's not quite that, but close enough,
I'm
right?
just excited that we still get to work with XML.
Old school.
Yeah.
So with the DAC pack, you can do schema compares because the entire schema is encapsulated, right? So you can say, what is the difference between the schema that's described in my DAC pack versus the schema that's described in my dev database? And it will say, these things are different, and these are the scripts that you need to run to change your dev database so it looks exactly like your schema, your DAC pack. And then there's another task that will just go ahead and run that script so it changes your database schema to match what you think it is, right? Or what it should be.
So the last time I had to do this manually was 10 years ago, writing a script to automate the comparisons. Sounds like the tooling has come a long, long ways.
The tooling has come so far, right? There's another set of tools that I really like using as well, and I'll give a shout out to our partners at Redgate.
Sure.
So Redgate has some database tools that are absolutely fantastic as well. So SSDT is basically state-based, right? So this is the state of your database, what it should be, and here are and I'll auto-gen for you the scripts that will change it from this particular state to the state that it needs to be at.
Okay.
So at Redgate, it does have state-based as well, but they also do versioning, right? From one version to the next to the next. And I really like that because you have super fine-grained control over exactly what happens. So basically, it's like, okay, I add a column. So from version 0, there'll be no column. From version 1 now of my database, I'm going to add a column. And so these are the scripts I have to run that goes from version 1 to version 2. Right?
Okay.
The nice thing about that is now I can say, before I go from version 1 to version 2, let's go ahead and take this data, move it into a temporary table, move it into the column, right? So now you can.
Now you can stage your actual data and schema kind of changes together.
You have more control over exactly how your data will behave as part of that.
Or we can just change to a NoSQL database and not have to deal with schema changes.
Yes, that would be fantastic as well.
But we lose relationships.
Yeah, and we have a ton of old projects, right? What are you going to do? Are you really going to change out the entire database?
You can't ignore that world. I was being a little tongue-in-cheek there.
Yeah.
But
no, I do love NoSQL as well. But sometimes you really do need the relationships as well, too.
Well, a lot of
So
times projects will have both, right? They'll
Yep.
have a SQL aspect for what makes sense for that, and then a NoSQL aspect. So.
Yep.
But it's good to know that that can all go as part of this pipeline.
Yeah.
Now, you showed me you can just keep kind of the end of the gate open, or you can have like this manual step. Is there any way to automate approvals?
Actually, you absolutely can. We have something called automated approval gates as well.
Okay.
So before and after each environment, you can use these automated approval gates, which uses automation and AI to help you decide should this gate pass or fail.
Okay.
So to give you a quick example, let's go ahead and jump and look and see what that looks like. Out of the box, you get, I think, 5 different gates that you can just start using. Right?
Okay.
So we'll work from the ground up, from the bottom up. The first one is the security compliance assessment gate. And this is super cool, right? It uses your security and compliance assessment for your Azure resource group to help determine if your gate should pass or fail. So
Wow.
if somebody tweaked my ARM template and did something bad, this will catch it and be like, no, it's not passing our security compliance rules. Right?
Nice.
Yep. So another thing that you can do is you can do a query for work item gate. So this gate uses a work item query to help you determine if the gate should pass or fail.
Okay, so if I don't have certain stories that are marked complete, don't deploy it.
Don't deploy it. Yep.
Okay.
So one of the ways that we use it internally with the Azure DevOps teams is we look for blocking bugs.
Okay.
If there are any blocking bugs out there in the system, block, just, you know
Stop
what, fail it, stop it.
Right.
So our deployment is pretty massive, right? It's Azure DevOps, the product, it's a global system. So,
Sure.
The deployment actually takes an entire week to go from I press the button into the entire world. At any point in time, if we need to block that, we don't have to like find some special place and right click and do what, no, we just create a blocking bug and bam, it just stops it immediately.
So my question there, though, is if Azure DevOps is using Azure DevOps for Azure DevOps, which came first, Azure DevOps or Azure DevOps?
Azure DevOps.
Okay, good. Glad you cleared that up.
It's even better because everything is hosted in Azure as well, right?
Right.
Including the code that was written for Azure. It's so Inception, it makes my head hurt.
Well, I think this is important for people to know and understand, though, is that, you know, it's kind of almost derogatory sounding term when you say dog fooding, like you have to eat the dog food. But we use our own tools. We're not just presenting a service and then in the back end not following unit testing, not doing continuous deployment. Yeah. And that probably gives us unique insights into what the challenges are of doing this at scale.
Yeah, we literally use this every single day to not only build Azure DevOps, but to deploy Azure DevOps as well. What's kind of nice is we get to use our software engineering team as our first line of testers, right? So the first thing that we do when we're ready for a new release is we release it internally to us.
Right.
And then we sit there for like 48 hours and we're all using it in our day-to-day life. And this is what we use to manage all of our work. And if we run into bugs or if the performance is down, we're using telemetry for everything. We're gathering telemetry. So if the telemetry is off or whatever, bam, it will just automatically stop as well.
Nice.
So that of course goes up to my next gate as well, which is the query for Azure Monitor alerts, which uses Azure monitoring to help you determine if a gate should pass or fail.
So if I suddenly have an endpoint that's crashing or responding slowly, or I can set actual business metrics as part of my automation.
Yes, you can say, you know what, if the response time is more than XYZ, then throw alerts. And if there are enough alerts, we're going to block this because the performance is just too bad.
Got it.
Right. Very, very powerful. So the last two gate is the invoke REST API and the invoke Azure functions. So this is the extensibility point. You can write an Azure function or a REST API that will get called by the gate, which means this is just custom code, right?
So that pretty much opens it up to anything.
Anything.
If I can write a piece of code that responds to
anything,
a REST endpoint, I can create a custom gate.
Yep. So 2 gates that I've written, right? Just right off the bat, 2 gates that I've written. I was at a hospital that had a horrible rule. Well, for whatever reasons, they have interesting rules. It's healthcare. You literally could not deploy into production without a document that was signed, uploaded to their DocuSign server.
Okay.
So this became a bottleneck in the deployment. Because first we have to track down the doctor and be like, dude, you need to sign this paper, and then you need to upload it, and then once it's uploaded, it needs to be verified by somebody, and then it can finally move on. And then sometimes people didn't check, right? They just said, F that, I'm sick of waiting, just pump it on through. And then you get in a huge amount of trouble once like HIPAA or whatever else becomes involved. But the big thing was it was just a bottleneck. So what I did was I created an Azure function that checked DocuSign and said, hey, is this specific document signed for this particular release? If it has been, let's go ahead and pass it. And if you look at it, so I deployed into QA, testers looked at it, everything looks good, they approved it. And once they approved it, my automated gate kicks on. So
Oh,
now
look at
I'm
that.
checking. So when you create a gate, you set up the polling frequency for your gate, and you also set how long do you want the gate to run until it times out. So I basically said, no, this is demo code. So I said run for every 5 minutes, and then let's run for 24 hours.
Okay.
But you can really tweak that to whatever you need it to be. So deployed into QA, QA tested it, looks good, they approved it. I immediately checked DocuSign. Has it been signed yet? Nope. Another 5 minutes later, has it been signed yet? Nope. Another 5 minutes, has it been signed yet? Yes. So great.
And then opened it up. That's amazing.
So this is just code, so you can literally make it do anything. So I was at another client where they're like, okay, Azure monitoring, that's great, but we're all on-prem and we're using Dynatrace. So can we use Dynatrace to help us determine if the gate should pass or fail? And I was like, of course you can. I didn't know, but it's code, right? You can make code do anything. Dynatrace has a great set of APIs, so literally, once again, I deploy into staging, and after I deployed into staging, I run a whole series of load tests as well. And so Dynatrace is collecting information in the background. And as they're gathering up all of their telemetry, when I hit my gate, now I start asking Dynatrace,
Are we good?
given these parameters that I want tracked, are we good? And they told me, no, you're not. Your response time is way too slow. Bad code never reaches production. Right? So you can make these gates literally do whatever you want. If you go to the marketplace, you can see where our partners have created automatic gates as well that you can just download and start using yourself.
Now, when I hear the announcement that if I have open source and GitHub, I can use Azure pipelines, is this functionality available to me?
Absolutely. Yes, 100%.
So I can build gates and automate them and do all of that with my open source projects
All of
using.
your open source, and it's super, super easy to do. And you know what? We should actually have an episode where we do that. Super easy.
I think you just signed us up for
Another one more, right? We thought
Yeah.
we were getting close. But yeah, it's super, super easy to do. It's literally just like you need to install the Azure Pipelines extension for GitHub. And then from there, you select which repo you want, and then you're in business.
Nice.
Then you drop into this UI, and away you go.
That's great.
Yeah. The other thing that I wanted to show you, the last thing that I wanted to show you is you can make these pipelines as complicated or as simple as you want them to be, right? So the first pipeline that we showed is pretty simple. We're just deploying the web front end.
Boom, boom, boom. Yep.
But remember, the Hotel 360 app is a lot more complex than just a web front end. You've got a web front end that's a .NET Core app, and then you have an API layer as well that needs to run inside of a Kubernetes cluster. And
Sure.
there's also a mobile portion of that as well.
Right.
So you can create, and once again, you don't have to do it this way, but you have the possibility of creating one pipeline that does everything for you. So here's my one release pipeline that's actually 3 parallel pipelines. One for my web front end, we've already seen exactly what it does. Another for my API layer, where I'm deploying into a Kubernetes cluster. Right? So
Okay.
I'm using Helm to deploy my Helm application into a Kubernetes cluster. And then finally, I also have my mobile portion where I use App Center to deploy to my alpha testers, beta testers, and eventually all the way out even into the store itself. Oops, wrong task, here we go. Right, all the way into the Apple App Store itself.
Nice.
So these pipelines, all of our demos, we show just like plain simple demos, but you can make these pipelines literally do anything that you need to, in front of your firewall, behind your firewall. So a lot of times people ask me, how do you deploy behind your firewall, behind my firewall, right? You need to install our agent behind your firewall. So this agent, it needs to be able to see, this agent needs to be able to reach out to Azure DevOps, the product, and it needs to be able to reach whatever machines that it's deploying to.
Right.
And if you wanted to, you can install an agent onto each machine that you want to deploy to, or you can have it on a proxy machine that just deploys onto those machines.
But that's important to note because it reaches out. So it goes out and asks Azure for the information. So you don't have to do anything funny with the firewall to open incoming requests.
Correct.
You're not exposing it.
Exactly. You do not need to open up your firewall, which is huge, right? So it just reaches out. Installing this is super, super easy. And I know we say that all the time, but literally, you just go into your organizational settings. And from here, let's go into our agent pools. And you'll see inside of the agent pools, it's going to give you a download agent link. And if I click on that, You download this, and depending on whether this is going to be a Windows machine or a Mac machine or whatever, you just run the script.
Nice.
And hooray for that, you're done. That's literally it. Well, you answer a couple questions and then you're done.
Right.
Right. So it's super, super easy to do. In front of your firewall, behind your firewall. If you're going into the cloud, you don't even need to have your own agent. You can just use our hosted agents as well.
Right. So we have hosted agents, but in the case I was at a previous company that had a dedicated build box, they spent the money on it, wanted to use it. So we orchestrated everything in the cloud, but the actual build took place on this one machine. So we were able to utilize the resource, but still take advantage of the flexibility.
Absolutely. Yep.
Very nice. That is incredible. Thank you so much for showing me Azure Pipelines. It looks like it's a piece of flexible technology that sort of has all the moving pieces someone would need. So I'm glad I was able to learn about it.
Awesome.
Hi, I'm Jeremy Lickness. You've watched another episode of On.net. Thank you for joining us. Be sure to like and subscribe so that you don't miss a show. And if you're interested in more shows, check out the link right here. Thanks.